In the vast and intricate tapestry of the periodic table, certain elements stand out not merely for their scientific intrigue, but for the profound dangers they pose to human life and the environment. Among these, polonium-210, plutonium-239, and mercury emerge as particularly lethal, each with a unique profile of toxicity and reactivity that underscores the delicate balance we must maintain with the natural world. Polonium-210, a radioactive element discovered by Marie Curie, is infamous for its extreme toxicity and radioactivity. Just a minuscule amount, roughly the size of a grain of salt, can lead to devastating radiation poisoning. Once ingested or inhaled, it emits alpha particles that wreak havoc on cellular structures, leading to acute damage to organs and tissues. The symptoms may start subtly: fatigue, nausea, and hair loss, but they escalate rapidly, culminating in multi-organ failure and death. The case of Alexander Litvinenko, who was poisoned with polonium-210 in 2006, serves as a grim reminder of this element's lethal potential, illustrating how silent and insidious its effects can be. Plutonium-239, another notorious radioactive element, poses a different set of risks. It is not only a key ingredient in nuclear weapons, but also a source of severe health issues for those exposed. When inhaled, plutonium can lodge in the lungs and remain there for decades, emitting radiation that can lead to lung cancer and other malignancies. Its presence in nuclear waste adds another layer of danger, as it can persist in the environment for thousands of years, posing a long-term risk to both human health and ecological systems. Mercury, though not radioactive, is a potent neurotoxin. Its ability to bioaccumulate in the food chain means that even small amounts can lead to significant health problems. Exposure to mercury can result in neurological damage, affecting cognitive function and motor skills. The infamous Minamata Bay disaster, where industrial discharge led to widespread mercury poisoning, highlights the catastrophic effects of this element on communities and ecosystems alike. Cadmium, another heavy metal, similarly wreaks havoc on the kidneys and bones, leading to conditions such as osteoporosis and renal failure. These elements, while perhaps less sensational than their radioactive counterparts, are equally insidious in their capacity to inflict harm. Then there are the volatile elements like francium, which, while rare and highly unstable, exemplify the dangers of reactivity. Its extreme instability makes it a fleeting presence in the natural world, but its potential for explosive reactions serves as a cautionary tale about the unpredictable nature of certain elements. Synthetic elements like Oganesson, with their uncertain properties, further complicate our understanding of elemental dangers, as the very act of their creation raises questions about stability and potential health impacts. In addition to these, we must not overlook the non-radioactive threats posed by elements such as fluorine and chlorine trifluoride. These substances are not only highly reactive, but can also lead to severe chemical burns and respiratory damage upon exposure. The silent nature of many of these elements, coupled with their resistance to detoxification, makes them particularly dangerous. Emerging research into heavy metal nanoparticles is shedding light on new health risks, as these particles can penetrate biological barriers and accumulate in tissues, potentially leading to chronic health conditions. The environmental dangers posed by radioactive waste, particularly from nuclear power plants, cannot be understated. The potential for weaponization of these elements adds another layer of urgency to the study of their properties and risks. As we continue to explore the periodic table, it becomes increasingly clear that understanding these elements is not just an academic pursuit. It is a vital endeavor to protect human life and health. The implications of our discoveries extend beyond the laboratory, informing policies and practices that can mitigate the risks associated with these deadly substances. In a world where new elements and compounds are constantly being discovered, the importance of vigilance and research cannot be overstated. Our survival may very well depend on it.